be an inelastic punch because you're riding with a punch. So the final velocity, and then if you do so, so inelastic is when they're together, and the elastic is like when he punches you and it goes back. So the final velocity for inelastic would be less than the final velocity for elastic, making the momentum less. That's what I put. I did the math for that. That's what I put. I don't know if I'm right or wrong about that. I'll text Miss Kelly in the thing and I'll get back to y'all. But that's what I put so far. Yeah, because I got like when I put like subbed in numbers for mass and like velocity, and I got that if you do an elastic, if you ride the punch, it'll be a less velocity, which would mean that momentum is less. I don't know if that's right because I'm talking about like riding the punch. I'm not talking about time. So yeah, I don't know if I'm right about that, but I knew I'm right about these. Move on to this. Boop. So get my eraser. Oh, it's 11:21 a.m. I have time before my next class. Anyways, moving on to the next question. Question 1. A mass of 10 kilograms is moving at 10 ms with a force, and a force of 9 newtons is applied for 2 seconds. What is the object's final velocity? So we're going to be using guess here. So our guess is that m equals 10. Our v of initial velocity is 10 as well. Our force is 5, and our time is 2. So our unknown is v of f, and the equation we're going to be using is J equals F times the change in time, which is equal to the change in momentum, which is equal to mass times final velocity minus the initial velocity. So we're going to sub our numbers in. So we got J equals 5 times 2 equals momentum, which then equals 10 times v of f minus 10. So then we're going to do our solve. So 5 times 2 is 10, which would be our momentum. So 10 equals 10 times v of f minus 10. Then we would divide both sides by 10. So that cancels out. And 10 divided by 10 is 1. So 1 equals v of f minus 10. You add 10 to both sides.